Hello, we're going to talk about the relation between Cartesian and polar coordinates. So if we had a complex number, we can write it as a plus bi, right? Good. And its Cartesian coordinate would be, ab, right? That's our Cartesian. Now, we can come up with an expression with this pretty simply uh, with using trigonometry, right? So we can talk about, let's start with the cosine of theta, right? The cosine of theta, our argument, right? Our cosine of theta would be our adjacent over our hypotenuse. So it'd be a over b. And then I'm sorry, I will call this not a over b, but a over uh, our modulus, which is r, and then I could solve for a, right? A is equal to r times the cosine theta. And then I could do the same thing for the sine of theta, right? So I can say the sine of theta is going to be the opposite over the hypotenuse, so it's going to be b over r, right? And then I can solve for b and say that b is equal to r sine theta, right? R times the sine of theta, right? And then now I know my complex number. After substitution, I can represent it, and if I substitute my a, it's r cosine theta, right, plus r sine theta I, right? And then we can factor out the r, right? And then we have cosine theta plus I sine theta. Good. And this is what we call our this is called our modulus argument form, right? Modulus argument form is this guy right up here, right? This is the modulus. And we also write this shorthand way. The shorthand way to write this, because we don't have to write this, is we'll say that we can also use this, and we call it RCIS of some angle theta. And, it's called the modulus argument because we have the modulus r, and the argument theta. Modulus is our magnitude of our vector. That's a complex number, and our argument's the angle. Is the angle that gets us to where our position of our complex number, right? And this is the shorthand way to do it, right? But we can also figure out what this theta is, right? We know that if we were to take theta, we find out what this angle is. We know that's the tan inverse of opposite over adjacent, right? So that's b over a. So we can use all this information to convert a complex number in Cartesian coordinates into a modulus argument form of a complex number. So we're going to see how to do that. Oh, and remember, we can also find out our r by taking the magnitude of the complex number. It's a squared plus b squared. Remember, this is our magnitude, which is our modulus of our complex number. So we can use all this information to convert back and forth between Cartesian and polar coordinates. So first example, it's going to ask us to express these complex numbers in Cartesian form, right? Giving your answers exactly, right? So I know that my magnitude's 4, so I know z for z of 1. So I'm going to go, let's see, z of 1, right, is going to be 4 times, it's going to be the cosine of 60 degrees, right, plus I sine of 60 degrees, right? Good. And what is the cosine at 60 degrees? The cosine at 60 degrees is a half, right? Plus the sine at 60 degrees is going to be root 3 over 2. So it's going to be root 3 over 2i, right? And then I can finish this up by saying multiplying the 4 through. So it's going to be 2 plus root 3i. So we took the argument form right up here, And well, they just told us the modulus an argument, and we're able to convert it into our Cartesian form. So for the other guy, here they gave it in this form, right? And now we want to write this in complex number. Well, this z of 2, that's the same as 2 times the cosine of 5 pi over 6, right? Plus I sine of 5 pi over 6. Good? So that's the modulus argument form. So this is going to be equal to 2. What is the cosine at 5 pi over 6? Well, that's going to be a negative root 3 over 2, right? Plus I sine of 5 pi over 6. Well, that's just going to be a half, right? Good, a positive half. And then when I multiply this through, z2 is going to be a negative root 3 plus I, right? And then that's our Cartesian our Cartesian form of our complex number. So there you go. So we use the argument form. Next problem we're going to look at, it says express these complex numbers in modulus argument form. So this is going to be, it's a little bit easier going changing something into Cartesian, but back we have to be a little bit careful. We got to take reference of the where it is on the graph. So this is z negative 1, right? Well, first let's find out our r or our modulus, right? That's going to be the square root of 1 squared plus a negative 1 squared, right? Well, that's just going to end up being the square root of 2, right? And then we know that the theta is going to be the tan inverse, or our argument tan inverse of this guy over this guy. So that's just going to be a negative 1, right? And that information, tangent of negative 1, is a negative pi over 4, right? So now I can write this complex number. I can say z is equal to, I can say root 2 CIS, shorthand way, negative pi over 4. If you want to write out the long way, where it's cosine negative pi over 4, I sine of pi over 4, you can do it that way too. So that's the first one, right? And that one works out. And there you go. And make sure you check with the graph, right? Because this graph right here, where would this, if you were to graph that, where would that work, right? It would be over 1, then down 1, right? So it would look something like this, right? That's my complex number, and that's z, and that's good. That works out. Negative pi over 4 gets me there, right? But the next one, we got to be a little bit careful, because what would the graph look like? This one here, it's going to be in this quadrant, right? It's going to be this way, right? Negative root 3, and then up 1. It's not the scale, right? So it's in this different quadrant. The reason that's important is because of the angle. Our tan inverse only gives, our tan only gives us values between here and not here, and not in this quadrant. So we got to be careful of that. So first, let's just figure out using this guy right here. What is the argument, or the argument of that? Well, that's going to be root 3 squared. Root 3 squared is just 3 plus 1 squared is 1. So it's just going to be 2, right? 4, the root of 4. So there you go. And now let's find out our angle, right? Our angle is the tan inverse, or our argument of, it's going to be 1 over negative root 3, or a negative root 3 over 3, right? Good. And that would end up being a 60-degree angle over here, a negative 60-degree angle, right? But that would only give us this angle right here, or not a 30-degree angle, or pi over 6, right? Or a negative pi over 6. But we're in the wrong quadrant. We're going to go over here. So we need to be, this is going to end up being the actual angle theta we're going to have is 5 pi over 6. And then our final answer is our z is 2 CIS of 5 pi over 6, right? And there you go. And that's the answer. Thanks, guys.